version because I fixed it. So it's question number 3. I forgot the +4 there, so I did it incorrectly. How many of you downloaded it before noon? Okay, yeah, so just, I'll show you what to fix when we get to number 3. All right, but if you were to download it from this right now, you'll get the correct version. So let's talk about the quiz here. So let's go ahead and start class, you guys. Videos, please. Thank you. Oh, Lauren, I had a question for you. Well, I'll ask you later about Mexico, like what the cost of certain things are. Because I know when I go to like Cabo, that's the tourist area, so I'm sure they're jacking up the price, but I was just curious. Anyway, it's not important. I just remembered.
Okay.
Anyway, hello, how are you doing?
I'm good. How are you?
Not bad. It was just I had a question about so I had a question. So like, if you go to, let's say you have an average lunch here, like let's say somewhere like In-N-Out Burger or McDonald's or whatever. It's like $7 or $8 or $9, right, for the lunch, like burger, fries, and soda. How much will like an average lunch be in Mexico?
Well, I feel like if you go to like a tourist area, that's where they tend to like jack up the prices.
No.
Like,
I know the tourist area. I'm talking about like where the locals live.
oh, locals, I feel like street tacos probably like what was it? I paid for my cousins and mine food and it was like 7 of us and I think I spent like less than $20.
For 7
We
people.
all Yeah, and we all like got like 3 tacos minimum. Some people got like 5 and quesadillas and like drinks and everything else.
Wow.
Super
Okay.
cheap.
But wouldn't you be paying in pesos or you paid in dollars?
Yeah. No, I paid in pesos.
Okay. All right. So yeah, I was just curious. Well, because yeah, I know in tourist areas, anywhere you go, like I traveled to a bunch of different countries, the tourist area is always more expensive. Let's go ahead and start here. So what was I going to say? Daniel says, sorry, I'm at work. Okay, no problem. Okay, so number 1 was a pretty easy question. You guys got it right. Number 2, I'm sorry, number 1, part B now. Here's what I want to see on a test or future quizzes. You got to show me the rewrite from here to here, then show me how to take the derivatives. So I'm very picky that you show me that 2 over x to the 4th is rewritten as 2x to the minus 4. Then you use the power rule you got here. Now, once you get the final answer, that, or you could write it like that, or you could write it like that. I don't care which one of these 3 you write it at. I'm very picky about you showing me the rewrite. The issue is when some people don't show anything and they just go from here to here. Well, I'm like, well, that's great if you can do it in your head, but if you want credit for it, you got to show me the work, okay? So you can't just go from 2 over x to the 4th to 8 over x to the 5th. I want to see the middle step that you rewrote it, okay? All right, so next, number 2, find the derivative using the limit definition of derivative. So I did the preliminary work, f of x plus h is that. So notice how I write it out. I wrote the derivative here. Hold on. Let me change it to the derivative is equal to limit as h goes to 0 of the difference quotient. So this is my f of x plus h minus f of x all over h. All right, someone is asking me on the chat, am I going to post the answer keys from the quizzes? Well, I posted this quiz 3 answer key. Generally, what I do is I just go over the quiz the very next class meeting. So every Tuesday, beginning of class, I went over the previous quiz, and you guys just write it down. The reason why I posted this one is because I want you guys, I wanted to explain to you You need to learn how to write it down properly. So this was a lot to write, so I went ahead and wrote it for you. So, and just in case if in case, you know, people are having issues with internet, I can say, all right, I posted it. This is how you want it. I want you to do it. All right. So, anyway, so make sure you write it out properly. Limit as h goes to 0 equals that, and it simplifies. See how the work flows, and you can watch it and going down and go. Now, a lot of you did it nicely, but some people not so much. And some people write it like this. They go here, then they go here, then they go there, then they go there. You know, make it flow like this. All right, anyway, any questions on that? No questions. All right. So let me answer some questions from the homework, and I will go over the review sheet as well. So I know the product rule, quotient rule, chain rule, we went over that last time. I'm sure there's some questions on that. So any questions on the homework? Last time we did section 3.4 was the last section that we did. So let's go over questions from sections 3.2, 3.3, or 3.4. Any questions?
Yeah, could we do question number 19 from 3.2?
Yeah, 1 second.
Okay.
Okay, so I generally don't like to use S's as a variable because it starts looking like a 5 and it gets confusing. But this is what the book has. So y equals S minus the square root of S over S squared. So just FYI, these are all S's. There's no 5 in the problem yet. Here's the thing. Whenever the denominator has just one term, I actually don't like to use the quotient rule. I like to just split it among each term. And by the way, the square root of S is S to the 1/2. So what I just did is I rewrote the S squared underneath each one. You can do that when the denominator is one term. So then let's see, when you're dividing two terms to the same base, you subtract the exponents. So this is x to the first divided by s to the second. So when you divide, you subtract the exponent. 1 minus 2 is negative 1. Minus here, 1/2 minus 2 is negative 3/2. So now we're ready to take the derivative. So we're going to go negative s to the minus 2. This negative 3/2 times negative 1 is plus 3/2 s to the minus 5/2. And that would be it. I'm sure the back of the book writes it in a different way. Do they write it as one fraction?
Yeah, I remember they definitely did write it differently. I think they had things on the bottom, which is why I was confused, but that looks right. Okay, thank you.
Let me see what they did here. This is 3.2 number 20, 3.2 number 2019. Okay. Yeah, so what they did is they wrote it as one fraction. So they got a common denominator. They did a bunch of stuff. Don't worry about it. All right, any other questions on 3.2, 3.3, or 3.4?
How did you get s to the 1, the second line? Can you explain that, please?
So this s is s to the 1, and s squared is on the bottom. S is the same thing as s to the 1.
Okay, thank you.
3.2, number 11. f of y. So now in this case, y is playing the role of x, so to speak. It's your variable that you're taking the derivative with respect to. So what you want to do here is, well, first let me rewrite it as y to the minus 2 minus 3y to the minus 4 times y plus 5y cubed, like that. Now we got to use the product rule because this is a product. So this is like the first part times this is the second part, and I'm going to use the product rule. So f prime of y is equal to, I'll wait until some of you catch up here. So first, times the derivative of the second. The derivative of the second, well, derivative of y is 1. The derivative of 5y to the third is 15y squared. Plus second times the derivative of the first. What's the derivative of the first parentheses? Well, it would be negative 2y to the minus 3 plus 12y to the minus 5. So let me recap what I did here. So this is first times the derivative of the second plus second times the derivative of the first. So the derivative of the first, what I did here is negative 2y, and then subtract 1 from the exponent, negative 3. This is negative 4 times negative 3, so it's plus 12y to the minus 5. Now, on a question like this, I would just say, take the derivative and stop. I don't want you to spend a whole bunch of time trying to FOIL all this out, FOIL all that out, try to combine some like terms. It would just be a mess. Let's see what the back of the book does here. Oh, yeah. It would be just a lot of busy work. I'm not going to do it. Let's go on to, let's do something from 3-4 where you had the chain rule to deal with. Anything on 3-4 you want me to do? If you don't pick one, I can pick one. Number 15. All right. So here's the thing. This is one of the things I don't like about this book. The chain rule is something new to you. And the author is already, well, okay. So let's not worry about e to the t because we're not doing that right now. So that's not going to be on the test, exponentials, but I'll gladly do it for you when I cover exponentials. Let me just pick something for you to do here. I'm just going to make one up here. F of x equals the sine of x to the fourth plus tangent of x. Let's do that. Now, what kind of function is this? This is a sine function. It's sine of something. How do you take the derivative of sine of something? Well, the derivative of sine is cosine, right? So the derivative of sine of u is cosine of u. Now, u happens to be all that stuff in the bracket. So let me explain. So if you have y equals the sine of u, the derivative would be cosine of u times the derivative of u. That's what the u prime is. That's not u to the first, that's u prime. So going back to this main problem, what's the derivative of u? What's the derivative of what's inside the bracket? 4x cubed plus, what's the derivative of tangent? Secant squared. And that's the derivative, that's the chain rule. So it was y, so it's if you have sine equals, sine of something, the derivative is cosine of that same something times the derivative of that something, which is all this. All right, let me pick another one here. let's do, okay, so I will do number 15 for you, but just remember, you got to remember the chain rule here. I'm not going to ask you exponential on this test, but just remember the derivative of e to the x is itself. So what's the derivative of e to the 5x? It would be itself, and then the chain rule times the derivative of the exponent, which is 5. Does that make sense? Addison? No? Yes? Okay. You had a poker face, like, I'm not going to tell you if I get it or not. So here's what I don't like about this book. They have f of t is equal to e to the at times the sine of bt. Now, generally in math, letters like a, b, and c are constants. Letters like x, y, and z and t are variables. Now, having said that, if you're just a calculus 1 student in math, how are you supposed to automatically assume that? It's kind of tough. So there's nothing here. Well, they wrote f of t equals, so we know t is the variable. Sometimes they don't even write f of t equals. So then you don't, if it's like y equals. So you have to understand that you're taking the derivative with respect to t being the variable. A is just a number, like 5 was up here in red. And b is just a number. So before I do that question up here, let's just change the question for you. If I were to say f of t equals, take the derivative of e to the 5t, that's supposed to be a 5, times the sine of 3t. Let's just do this problem, then I'll explain how to do that one. So this is a product, and we got to use the product rule, okay? So this is the first part, this is the second part. So f prime of t is equal to first times the derivative of the second. Now, what's the derivative of sine of 3t? It would be cosine of 3t. And then you got to use the chain rule times the derivative of the inside part. Well, what's the derivative of 3t? A little louder. 3, yes. Plus second times the derivative of the first. What's the derivative of e to the 5t? Well, it would be itself because it's an exponential, but then the chain rule times the derivative of the exponent, which would be the derivative of 5t, which would be 5. Now, that's the answer to this. I would probably redo it and rewrite it as put the 3 up front. It's not wrong, but it just looks better if you do it this way. And the back of the book will probably factor out the greatest common factor and so forth. Now going back to this top problem with the A and the B, that would be done the same way, except anytime you see a 5 here, replace it with an A, and anywhere you see a 3 here, replace it with a B, and it would be the same thing. Because A and B are just constants, just like the numbers 5 and 3 are. Does that make sense? So you don't treat the letters A, B, C, and K as variables. Those are, unless say otherwise, you treat them as constants, and you treat letters like X, Y, Z, and T as variables. All right, anything else you want me to do from section 3.4? Did I do 3.211? I don't remember. Yeah, you go. All right, so let's go into the review sheet, then I'll answer some more questions from anything from the book as well, and then go over some other things that you should focus on as well on the. So, yeah. Aaliyah, you're going to really be impressed with my new thing. Instead of writing on the board, I have this already written out. Check this out. I can write on this, but then I can erase it. But my original writing comes back.
Very impressed already.
I sense sarcasm. All right. So I got to change this review sheet. It was number one was too simple. So limit as x goes to 2 of this. You just plug in 2 for x and you get -3. That's pretty straightforward. Any questions? Oh, Damaris, welcome. Glad you could join us. You're not driving in a car. You're not going to Arizona.
Nope, not this time.
I know a high school teacher, and she was asking, does any like of her girlfriends want to go to Hawaii for a month and just work from home from there? And I'm like, well, this working from home thing, I guess she's really. Hey, you know, now that I switched to the iPad instead of the whiteboard back here, I guess I could travel and teach as well, right? I just have to make sure I stay in a hotel that has Wi-Fi. So I can't be like at a Motel 6. Sorry, the Wi-Fi is not working today.
I mean, you could always use your hotspot if you're not in a bad signal area.
Oh, well, the thing is, I got to change my phone plan. I only get 6 gigabytes, and then it gets down to the really slow speed where you can't even go to Safari.
What phone do you have?
iPhone 10s. But my plan, I have an AT&T plan where it's 6 gigabytes where you get the full speed. After 6 gigs, it gets really slow because they don't want you to go past 6 gigs. But I think I got to change my phone plan.
Definitely. I can't get signal anywhere with AT&T, especially I live through the hills. And that's why when I went to my mother's place, I couldn't use my hotspot because the hills, no matter what carrier you have, it doesn't make up for the anything. And so that's why I go to Starbucks.
Ooh, wait, 6 gigs is like 100 megabytes per month. HRAM, where are you at?
Yeah, so basically my parents are the ones who control my phone plan, and they basically cheap out on the data for me, so I get screwed
But
up.
usually 6 gigs is a plenty for me because usually I'm either at home where I use the Wi-Fi for my phone, or at work, like before COVID, I'm at Cal State Fullerton or Fullerton College or wherever I'm using the Wi-Fi. So 6 gigs is plenty, but nowadays, like all these websites, they keep using more and more, and they start having videos running in the background. And before you know it, you use up 6 gigs.
Professor, that's the thing. So you get 6 gigs. I only get 100 MB. So that's like.
Yeah, but why are you complaining? Your parents are doing it for you.
I mean, I guess, but you know, I don't always have to be on Wi-Fi then. So
yeah.
No, we're a big family, so we all get we just made it for a business plan, and everyone just gets it super cheap that way because I think we're like 10 on the plan right now.
Oh, good Lord. 10 people.
Yeah.
Not all in the same house, right?
We used to be, I think, like 8 in the same house, and then I moved out, obviously. And then my grandparents as well are on the plan. And so I think there might be even more than 10, but it works out.
All right, so let's get to here. Anyway, number 2, prove limit as x approaches 3 of this. Now remember that this is for every epsilon greater than 0, there exists a delta greater than 0 such that if x minus 3, so that's your x minus a, is less than delta, then that's your f of x minus L. So your L is 7 is less than epsilon. So remember when I explained this to you, you start with this part right here, and that's what I wrote here, and you work your way down, and you simplify this so that it eventually, this is absolute value of x minus 3, which matches that. So once this matches that, then you look here, it's epsilon over 3. So therefore, you know, which you're going to choose delta to be epsilon over 3. So if 0 is less than that, then x minus 3, so since delta has to be less than epsilon over 3. Now from here to, how did I get to here? Well, that's just, you copy this going backwards. So notice this is the same thing as this. So you just go, then write the next line, the next line, and the next line, and eventually you'll get that, and that's the proof. So the proof is right here, it is on the right side, this area right here. That's the actual proof. All this stuff that I circled is on the left, that's preliminary work, so it makes your life of the proof easier. All right, so now going to question number 3, and this is all, by the way, for those of you who came in late, this is all already on your Canvas for you, so you don't have to copy this down. Number 3, now, if you downloaded this from Canvas before 12:15-ish, I had the wrong graph here. That's what I was talking about, Madison. I forgot the +4, so I had the parabola at the origin there. So now this is the correct one, although it's a little blurry. So f of x equals x squared plus 4 everywhere where x is not equal to 1. So I'll be more direct with the way I asked the question. I'll say graph the piecewise function. I didn't say that here, but I'll say graph the piecewise function. Then I'll say, then answer the question. What's the limit as x approaches something? So in this case, I was kind of wishy-washy, but it's a review sheet. So if you were to graph it, so it's x, basically it's x squared plus 4, except at x equals 1. What about at x equals 1? It's equal to 2. So there's that point right there. So now, looking at the graph, from the left side, it looks like the limit is approaching 5. From the right side, it's also approaching 5. So therefore, limit as x approaches f of x equals 5. And that's it. Now, I said from the left side, from equals to right side, equals 5. Now, this last part here, FYI, this is not part of the answer. It's just, I'm saying for your information, if I were to ask you f of 1, the answer would be 2. So again, if you downloaded the file before a few hours ago, please cross that graph out and fix it, or just download it again. It's fixed now. Any questions? All right, moving on to number 4. So on this one, limit as x approaches -1 from the left side of 1 over x plus 1. Now, 1 over x plus 1, I notice there's an asymptote here at x equals -1. So if you're going one-sided to an asymptote, you're going to go up either negative infinity or positive infinity. So in this case, I plugged in some values here. I plugged in -2 into here, and I got -1. And then I plugged in -1.1, I got -10, and so on. So it looks like it's going towards negative infinity. Now, you don't have to plug in -2, -1.1. Those are just the ones I chose. Someone else might pick -1.5, and then -1.25, whatever. Either way, you're going to get something that's going to go towards negative infinity, and that's the answer. Now, these are questions, some of them are like, some of these questions that I've been asking are a little weird, but I just try to see your understanding of it, just throwing different questions at you. Number 5. Oh, let me wait if you're still writing this down. Speaking of your phone plan, I sound like a grandpa sometimes. I go, back in my day, when I was a freshman in college, this is the late 90s or mid to late 90s, the minimum wage was $5.25 an hour. So we paid $5.25 an hour. That's what I got paid at when I was 17. I was not even 18 yet.
Where did you work?
I worked for a few months. I'll tell you my jobs. I don't have that many variety of jobs like my brother, but I worked at a Foster Freeze where we made and served ice cream. And then I worked at like a video game store, not GameStop, but it was like they sell Japanese and American games. This was in Torrance. I grew up in Torrance. And then After that, I was a math tutor for the Cal State Fullerton math department. That was just a few hours a week. And then that was pretty much it for my college. I didn't work that many hours per week. And I lived at home all the way up till my senior year. And then senior year, I just got a loan and grant, and I couldn't take the drive anymore. Then then once I became a grad student, Cal State Fullerton had it where you can teach like the lower math classes while you're getting your graduate degree. So I did that. And keep in mind, though, a rent for a one-bedroom apartment back then was like $650 for a really cheap one. That was when I first moved out. Maybe it went up to 700 or a little bit later, my second year of grad school. But it was pretty cheap. Now, granted, I went to a pretty cheap place. You know, I was 22 years old. I didn't care about central air, indoor washer and dryer. I just give me my own place. That's all, so I don't have to drive. Let's see here. Yeah. So then after that, and then once I got my graduate degree, then I've just been teaching. Oh, I skipped one job. I was a paper boy in 8th grade. Those are only the jobs. I'm only telling the jobs that I got paid for. I had other jobs that were scams, where you had to stand outside and try to get people to subscribe to the newspaper. This is later on. And I wasn't very good at convincing people to subscribe. I quit after a few days. I think I may have skipped some jobs. Well, those are the ones that I only remember off the top of my head. All right, moving on. Amazing resume. But my resume, believe it or not, after this semester is over, did I tell you I will have completed my 20th year teaching? 20 years of experience. Cal State Fullerton is going to give me a little clock with an engraving on it. 20 years of service at Cal State Fullerton. It's technically going to be 20 years at Fullerton College as well, but I don't think Fullerton College will do much. Maybe say, glad you made it this far. What do you want to teach now for next semester? All right. Yeah, I started fall 2001. That was my first semester not counting the grad school. So fall 2001, first semester as a lecturer. All right, moving on. Your dad just got a handshake for 20. Right. I'm not going to actually get the object. I think they'll give it to me once the COVID thing's over, but maybe they'll email me a little certificate. I'll show it to you. I'll share a screen. Oh, Aman, what does he teach? Oh. Okay. Let's get moving. We'll talk more. So I don't want to not have you guys be prepared. So number 5, f of x equals x squared here on the piecewise function. When x is less than or equal to 3, c over x when x is greater than 3. So let me explain to you what's going on here. So you guys all know how x squared looks like, but that's only when x is less than 3, right? Now, the question is when x is greater than 3, c over x, depending on what c is, it's going to be either like this or like that or like that, or never below the x-axis. I should probably make a better graph. So the question is, I want it to be this one right here so that it so-and-so connects to the blue graph so that it's continuous, right? Does that make sense? So the question is, I want them to, for it to be continuous over the whole real number line, I need them to connect. So I need x squared to equal c over x at x equals 3. So we'll say, all right, well, let's plug in 3 for x. So 3 squared equals c over 3. Solve, and we get c equals 27. So if c equals 27, then we'll get a graph that will look like this. How many of you got that before I did it? Maybe not the picture, but you knew the math.
Yeah, I guess that answer, but I'm still a little bit confused as to why we can use x as 3 for the bottom one, since it's supposed to be like x is greater than 3. I don't know. That was kind of confusing to me.
Yeah, I see what you mean. Because when it's leading up to 3, it's every value leading up to 3, 3.2, 3.1, 3.01 is always this. So it's got to approach, as it's approaching 3 from the right side, it'll be this.
Okay. Okay, that makes
And then
sense.
if it's approaching from the left side, it'll be this. And at 3 would also be this. So it all's got to connect from the left side. So this is from the left side, this is from the right side, and this is for 3 itself. At 3 itself, as long as it's one of these two, it doesn't matter because they're going to be equal. So it's more the limit. You're using this more for the right side.
Okay. Yeah, no, that makes sense.
All right, so I don't think I'm going to put a question like that on the test to kind of help you out. I'll tell you, you're going to see questions more like number 6 and 7 here, just to ease your anxiety a little bit. Not you, I mean like the whole class. So number 6, limit as x approaches -3 of this. So if you plug in -3, you're going to get 0 over 0. So you factor, cancel out, plug it in, and that's it. Go back to the section where you had problems like this. There's different ones. Maybe the factoring is a little bit tougher. Maybe you got to factor the top and bottom. Maybe you got to multiply by the conjugate. Go back to that section that you had a bunch of these types of problems. Focus on this, okay? I'm going to put a little star next to this. No reason. Lauren, did you get that? Stop talking to your friend. I'm just pretending. All right. Hey, last semester, oh no, Aaliyah, it wasn't your class. Last semester, it was my OCC class. I had one student, her friends were like in the background waiting for her to go out. They're like, I'm like, all right, it's break time. So like, are we gonna do anything important after break? I'm like, just go. Your friends are waiting for you. I look like a jerk here. Your friends want to leave, and just go drink. I mean, go do whatever you want to do. I'm just assuming it was drinking. Yeah, the people in the background did not look like they were gonna stay. All right. Anyway, moving on. Moving on. I'm gonna get myself in trouble here. Number 7. This is actually too close to the one that you just had on the quiz. I should have probably changed it, but I didn't know what I was asking on the quiz. But f of x equals that, f of x plus h equals that. So it's very similar. Go back and study questions like this as well. F of x plus h minus f of x. So limit as h goes to 0 of f of x plus h minus f of x all over h. Now, again, look at the work of art that I put. It's from here. You can read it. It flows. Not like some of your papers where it's like a maze to look at. Okay. Also, don't do what I did on here. Notice, here's what I don't want you to do. So let's say you don't have a printer and you're writing the test on your own piece of paper. This is what I want you to do. Number 4, then number 5, then number 6. See how, like, look at number 1, number 2, it just keeps going lower. Number 3, you just scroll down. It's never like go to the right, go above, go below. It's always to the bottom. Now, I didn't follow that rule here. Hold on. Hold on. My screen locked. One second. Oh, here you go. All right. So number 4, number 5, number 6. I'm looking at number 7. It's on the right. Don't do that. You got to go lower. You keep going lower. You're all saying, well, what if that's a waste of paper? Too bad. I don't care. You must have mistaken me for someone who gives a, who cares?
Professor,
All
how many
right.
questions will the exam have?
And I'm talking here. Any questions in it? I don't know. 12 to 15. Don't hold me to 12. Maybe there's parts A's and B's like 15, 16. I don't know. That's how I feel. Let's move along. So make sure you know how to do that. Get the proper notation. Make your work look like a work of art. Not nauseating to look at, like I want to throw up in a bucket here. Number 8. Now, number 8, if I say you only use the limit definition is when I say so, like number 7. Number 8, oh yeah, let me put a little star next to number 7. No reason. Is that enough hint? Okay. Number 8, find the equation of the tangent line. So just take the derivative quickly. Even if it looks like you can use the limit definition, don't do it because you're wasting time. Now, you do want to rewrite. I like to see the rewrite. Then this. Now, the only reason I'm going to rewrite it to negative 4 over x squared is because I'm going to have to plug in an x value. So that's why I'm writing. So please do not, and I repeat, do not do this. Just go from here to here. Okay? I want to see you rewriting it. So now once you're here, you plug in x equals 4. So that's, you get that. And then negative 4 over 16, which reduces to negative 1/4, and that's the slope. Then you take the slope negative 1/4, and you're going to plug it in for x there. Oh, hold on, not there. Into x, that's the slope, m. Now you plug in the 4 and the 1, that's the point in here, and then eventually you get this as your answer. So that's finding the equation of the tangent line. Make sure you know how to do something like this as well. And also, we also did the normal line. Remember to know how to do the normal line as well. Any questions? Can we do a normal line example? I just want to be, no, what do I look like? I just want to be safe. Okay, normal, remember it was just, once you get the slope, it's almost the same thing. Once you get to this point where the slope is negative 1/4, the slope of the normal would be the negative reciprocal of it, which would be positive 4 over 1 in this case. And then you use positive 4 over 1. Number 9. You can go back to your notes. We did it, and it was in the homework too. I think I did one of them in red, one of them in blue. Madison remembers that. She's probably the only one here that doesn't drink. All right. Number 9. Rewrite. Now take the derivative. So the derivative of this guy is right here. Negative 3 times negative 5 is 15, x to the minus 4. And you can stop right here. So you can have this as your answer or this. It doesn't matter. Number 10. Again, you rewrite it. Then you take the derivative. Now notice when I rewrote it to the second line, it's mainly because of the second term. Cosine is still cosine. I mean, you take the derivative of the whole thing at the same time. So you call f prime equals that. All right, now we're done. It's your answer is right here or right here. Either or, it doesn't matter. Any questions? It's really cool, huh? You see how I like erase it, but then my original writing comes back? The PDF file? Impressive, huh? See, look. All right, moving on. I did number 10, right? Number 11, same thing, product rule. Oh, it's a product rule though. So first times the derivative of the second plus second times the derivative of the first, and that's it. Any questions on 10 or 11? Oh, I had a question. Aman, what university or college or your that teaches at? Cal Poly? Oh, Cal State Fullerton or Fullerton College? Oh, just okay. I was thinking graphic design. I was thinking engineering, and for some reason I was thinking Cal Poly. Oh, okay. Yeah, please don't repeat any of my jokes, your father. I'm supposed to be an esteemed colleague. Using the word esteemed very loosely. All right, moving on. So number 12, we got to use the quotient rule. This is the bottom. Times the derivative of the top minus top times the derivative of the bottom all over bottom squared. Now, remember on a quotient rule, you simplify the numerator as much as you possibly can. So I multiplied it out, and from here combine like terms and you get that. And then this is the final answer right here. Rachel, what happened? Rachel went away from the keyboard. Lauren, how are we doing over there? So far, good? Well, what time is it where you're at?
I'm back in Fullerton now.
Oh, you are. Well, important question. When you flew back, did you fly back?
Yes, I did.
Okay. Did they make you take a COVID test to enter the country?
Like back into the States?
Yeah. Did they make you do a swab
No.
test to show that you have a negative test result?
Well, what I did was I drove to San Diego and I did the CBX, and then I flew out from TJ to my destination point because the flights are very cheap and they're direct flights. Because LAX usually don't do direct flights to Culiacan,
Mm-hmm.
so we just drove down there, and then we did a CBX back, and all he did was take our temperature.
Oh, so when you came back, you flew to TJ and then from TJ went to San Diego?
Mm-hmm.
Oh, and so you just crossed the border on foot then, not on plane. So that's why they probably didn't check.
The CBX is pretty much like a fast way to like cross the border like to TJ Airport.
Oh, you said CVS, you said?
CBX.
Oh, CBX.
Yeah, it's very convenient.
Is that what does CBX stand for?
I don't know what it stands for, but I've been doing it for a couple of years.
Is that the name of the border?
It's no, it's not the name of the border. It's just the name of that like little company that they do.
Oh,
They
okay.
have one for, yeah, they have it, I think, somewhere else, like on the borderline. But they
Mhm.
also have it like right there in TJ.
Yeah, because my friends want to go to Cabo in a couple months, and I'm like, all right, I'm kind of like that whole, you got to show a negative test result when you get back.
Oh, you do? When you fly
Oh,
back?
no, anyone coming in from, that's the new CDC guideline, that anyone coming back from another country, they need to show a negative test result. But then, but the hotels said they will do the test for us as a service because, you know, they don't want to lose business. All right, so hold on, there's a
Yeah,
question here.
what I did, oh, sorry. What I did was just get tested when I got home, and it was negative.
Okay, I'll ask more questions when the time comes. You will be my advisor for Mexico. Oh no, there's a question.
You can antibody test too. And if you have antibodies, you're good for 90 days traveling to and from internationally.
Oh, I haven't got the coronavirus yet. I thought I did last year, but. Professor, can you explain the 2x for B1? What? I don't know what B1. Can you clarify your question, Cassandra? Oh, B1. Oh, yeah. So this is, oh, I see what you mean. Bottom times the derivative of the top minus the top times the derivative of the bottom. Oh, that's B prime. Yeah, 2x, because the derivative of the bottom, derivative of x squared is 2x. Does that make sense? The derivative of x squared plus 1, well, 1 is 0, derivative of x squared is 2. Okay. Now, moving on to number 13. Now, one thing before I do number 13 is secant cube right here. Whenever you see secant cube x, that means this. So in my head or in your head, if you want to think of it like this, it will help. So just FYI, if you're taking the derivative of something to the third, it's 3u squared times the derivative of u prime. Oh, very nice. Thank you. Now, what we'll do here is, now let's go to this problem. So we're going to have to use the product rule. This is the first part. This is the second part. So first times the derivative of the second. So the derivative of x to the fifth plus 3 is that. So this is the first. This is the derivative of the second plus second times the derivative of the first. Now, the derivative of the first probably will give you some trouble, so let me explain that. Remember, I said derivative of u to the third is 3u squared times the derivative of u. So in this case, my u is going to be secant to the third. So if you have secant to the third, the derivative would be 3 secant to the second times the derivative of secant, which is secant tangent. And that's what I have here. Now, the only thing that I did, and then of course, the books and the formal way to write it is write as secant squared x, but that means the same thing, secant whole thing squared. Now you have secant squared here and another secant here, so that's why I wrote it as secant to the third. And then, of course, the tangent is still there. Now, you can just leave it like this, even though this guy and this guy, they have a secant to the third in common, but just you can leave your final answer as what I have here in the last line. Any questions? All right, we got one more question to do. So number 14 is actually just, you have u to the 5th. What I did here is with the 1 over x, I changed it to x to the minus 1. So you got u to the 5th. If you have u to the 5th, the derivative is going to be 5u to the 4th times u prime. So going back to here, that's u to the 5th, 5u to the 4th times the derivative of u. Well, what's the derivative of x squared? 2x. What's the derivative of x to the minus 1? Negative 1x to the minus 2. And that's it. All right, so that's the review sheet. I'm going to go over a few more other things after the break, like intermediate value theorem and a few other things to focus on. So let's take a 10-minute break. We'll start back up at 4:22.